Well, my name is Lloyd Brown. I am a systems admin at the BYU Supercomputing Lab. I have been for about 10 years. My first experience with Linux was with Red Hat 5.2, and I am not talking about Red Hat Enterprise 5.2. So that puts it in the mid to late 90s. This was an era where you had to recompile your kernel to get a printer driver, and recompiling said kernel took a day or two. So it has been quite a long time. Yeah. Okay. I am not, by training or experience, a developer. So what we're going to talk about today is a lot of what I would call systems administration, architecture, or operations, not development. Although I think it would be of interest, there is a certain tendency to, for developers and operations to butt heads. But let's not do that here tonight. I really am not up for an argument. As a quick disclaimer, I am an employee of BYU, of the Fulton Supercomputing Lab specifically, and despite the fact that a lot of what we're going to be talking about tonight is based on that experience, and Billy's as well. Billy helped me develop a lot of this. This is not, and despite the fact that I'm still wearing my work shirt, this does not represent any official positions at the university, its sponsoring institution, etc. No guarantees about anything, so be sure to check and make sure I don't lead you astray before relying on this. But the idea here is to give you guys some ideas about how we have chosen to set up some of our services to allow us to simultaneously keep them up and up to date, which has been a really big challenge. So, by a quick raise of hands, who is familiar with the rudiments of TCP and UDP lifecycle? Okay, so if I talk about a FIN packet gets sent in this scenario, is that going to be really confusing? I want this to be something that people understand, but I just need to be able to read the audience a little bit here. Specifics of the ARP protocol in particular, address resolution protocol. Okay. IP table setup, okay. Have you guys dealt with VRRP or conntrackd in particular? Okay. Well, we'll go over the basics, but that gives me some sense of how much detail I need to go into. All right. As I said, the basic motivation as a systems administrator is you need to keep things up all the time, period. End of story. Services must be available, and whatever service that is depends. But at the same time, if you let things get out of date, there are constantly security patches coming out. Recent examples are Spectre and Meltdown, pretty famous ones. They seem to be trying really hard to give them good marketing names so that people pay attention. What was the one, Ghost something recently? Yeah, you get the point. The point is that even the minor ones could be potential access points for data infiltration or exfiltration. They could cause availability problems. So in some ways, keeping software up to date is also a part of keeping the systems and services available as well. So but unfortunately, the problem is every time you need to update software, at least, it depends on the software, but frequently that means an outage. The classic examples are things like with Spectre and Meltdown, for example, that depending on your mitigation approach, you certainly had to update your kernel, which required a reboot. There are a couple ways you can maybe fake it, kernel replacement. Don't do it, it's painful. Probably a reboot because of the kernel update. You might need to update your system for some BIOS or other kinds of system level firmware. That's going to require a reboot. And so these two things, the idea of keeping services up and up to date at the same time, can cause some problems. These two things kind of work in conflict with each other. This is how we used to do it. We have a small shop of systems admins. Now that you've met Billy and I, you've met 2/3 of us. So it's a pretty small shop. We threw up some virtual machine infrastructure, a small SAN behind it, and stuck VMs up, and it was pretty naive, and it worked pretty well. You ended up in a scenario in which if there's a failure in your hypervisor, the virtual machine fails over, you're fine. So this means you can update your hypervisor, and that works great. We're not going to touch redundancy at the SAN level right now. That's a big topic, so we're not going to go there. But just assume your SAN is in this scenario is sufficiently redundant. But the problem this creates is pretty simple. What if the VM needs to be updated? Your virtual machine, it is a virtual machine, so it can move, and that's nice because it protects you against hardware failures. But if its software needs to be updated, well, then you're back to the original problem. Maybe you don't have a hardware failure-driven problem, but you do have an update-driven problem. If you have to update something that has a potential outage, then your services go out. And you can do things to minimize those outages, but this is something that we want to try to avoid. This is the solution we've chosen to land on. Now, this diagram shows virtual machines and hypervisors and local storage, all the redundancy being done at the application level. This same approach works sufficiently well with hardware, with operating systems and software running directly on hardware. You don't actually have to have a hypervisor, because in this scenario, the virtual machines don't move. Services move, but the virtual machines themselves don't. We achieved that through a couple of things. The VRRP protocol we'll get into, that's specifically, it stands for Virtual Router Redundancy Protocol, but it can apply to a number of things, not just network routing. So failure or patch and reboot doesn't matter, because the other virtual machine or the other host can take over. It's really pretty straightforward. These are some of the application level redundancy redundant services that we have deployed currently. These are not a complete list. And this runs the gamut here. So DHCP is redundant in many ways, pretty much built in. The IC DHCP daemon in particular has peering functionality, so there's no VRRP required. You don't have to do anything back behind the scenes. You just throw up a couple of DHCP servers and point them at each other, and they really do coordinate. If you have a pool of addresses, they periodically balance the available pool among them, and so on. And frankly, if you have static addresses assigned, so what if they both respond? It works. It doesn't. They're both responding with the same information. It doesn't really matter which one gets there first. We have set up MySQL with some active passive replication, postfix and dovecot, and in particular, we're going to use as a scenario here these Linux NAT servers. And really, it's pretty straightforward when you understand it. But this is kind of an example scenario we're going to base a lot of what we talk about tonight on. This does involve both VRRP and a daemon called conntrackd. We'll go into a little bit of detail about how that's done. So this is our example scenario. We have a LAN, we have a WAN, we have two NAT servers. In this case, they are hardware servers and not virtual machines for performance reasons. They each have a fixed address on the internal and external subnets, and there's a floating address both on the internal and external subnet. And those two float together through this VRRP protocol. Now, we're going to get to the details of this in a minute, but we also have set up some direct links between them so that they can share their state tables through that conntrackd mechanism. By the way, you're absolutely welcome to raise your hand and ask questions if any of this is unclear. I might talk too fast, so stop me if I do. This link down here at the bottom will take you to an external-facing wiki page that we describe this in more detail, including specific commands for setting up the packages that are necessary. In this case, on Debian, on the Debian Linux distribution, and so on. But just too much to fit into a slide. Okay, VRRP. Let's talk about that for a minute. So, a couple of people said you've done stuff with VRRP. How would you describe what VRRP does, essentially? One sentence. Too much interaction, I can tell you. Okay, well, that's all right. You can't know if you haven't dealt with it. That's fine.
Basically shared IP.
Well, and I wouldn't say shared so much as floating between them, but yes, that's the basic idea. It's a mechanism whereby individual servers, and you can do this on routers a lot of times, can essentially have an IP that floats between them, and they periodically announce their availability. It's usually using a multicast address, and so basically if one device hasn't heard from the other one in a configured amount of time, it takes over the IP address. Most of the time when you do this on a host-based system like Linux, as opposed to like a network switch or network router, which can also do these things, You have the opportunity also to set up hooks for various things like health check. If I'm setting up, NAT server is not a good example for this, but let's say I'm setting up an active-passive caching proxy, and I want it to be able to check and make sure that Squid is running, and maybe some sanity checks on making sure it's running well before it actually decides that this host is healthy enough to take over the IP address and participate in the election. You can also do some clever things with what we call node fencing. So so when one takes over, it can do things to force the other one to shut off, so you don't end up with split brain conditions where they both think they're the master. That gets messy. Don't recommend doing that either. But so there are various hooks and places you can do this. We usually use a piece of software called keepalivd. Is anyone here familiar with keepalivd or specifically the Linux virtual server IPVS mechanisms for load balancing? Okay, that is also a discussion in and of itself, so we're not going to go there. But keepalivd can be used to both handle the floating IP address and the setup of load balancing. If you want to have load balancing servers sitting in front of a series of what they call real servers back behind that provide the underlying service, the web service, the SSH logins, whatever it is. So keepalivd does a lot more than this, but we're going to use it as an example here. One of the things that you have to understand is with VRRP in particular is when something decides to take over, what happens? Well, it chooses to take over because it hasn't heard from the current master in a certain amount of time. So the IP address, it applies the IP address to the specified interfaces, and it sends a gratuitous ARP reply with a new MAC address. Now, for those of you who aren't familiar with ARP, ARP is essentially the mechanism whereby devices on the network can take a known IP address and say, what's the MAC address associated with it? Now, that if it's on the same physical, subnet, same broadcast, I should say the same broadcast domain, that is the MAC address of the device itself. And if there's a router in between, it's the MAC address of the interface and the router that you need to go through. And so it's a little bit complicated. But essentially, a device can send an ARP request and it gets a reply and therefore has a MAC address to use in the Ethernet layer when it's addressing packets. So that becomes the destination MAC address. One of the quirks of ARP is that there's very little security involved. And anytime any device sees an ARP reply, even if it didn't request it, it updates its local ARP table. And as a result, we can do what's called a gratuitous ARP broadcast. Essentially, it's an ARP reply. It just looks like any other ARP reply. Nobody asked for it, but it's an ARP reply. And so every device in that physical broadcast domain, on that layer 2 domain, updates its ARP tables. And so when a device takes over an IP address, it sends out these ARP broadcasts, essentially, so that everything that is looking to send something to that network or to that device, that IP address, knows that it's now on this MAC address instead of the other one. Is that clear? Is that idea clear? It's a little bit non-intuitive. You could argue that it does utilize a security hole in the protocol because this is exactly how you would do what's called an ARP poisoning attack. If you get physical access to a network, you can start sending gratuitous ARP replies, and you can essentially try to redirect traffic to you. It's the same mechanism. But let's assume for a minute that we're benign and we're not going to do a poisoning attack on ourselves. Okay. This is just an example. keepalivd.conf is relatively simple. Definitions, and I'll send a link to these slides, by the way, so you don't have to worry about it. Basic definitions of where to send email to, how to send it, where to send it from. Here's a VRRP instance. Where it go, what's involved in the instance, the IP addresses and what devices they're on, what devices to monitor. And here's some notify backup master and fault hooks. Those are essentially where we run specific scripts in relation to those events. We'll get into why we use those specifically in a few minutes. You don't have to worry too much about this, but just understand that it's a relatively simple configuration file. And then you might be asking the question, what else? It can't really be that easy. And the answer is, it depends. It always depends. It depends on what you're trying to accomplish. And it depends upon several things. In particular, do you need to preserve TCP sessions? So let's say, for example, that you're talking about a NAT server like we were talking about earlier. It's very possible for during a failover event for somebody to be downloading a huge ISO file or something. That TCP session is already open. You want to preserve it if possible. And if that's the case, then you need something to synchronize those TCP sessions and handle those. And we'll talk about that in a minute. That's the role that conntrackd fills. But maybe all you're really doing is you've got a small-scale web service, and all of your content is static, and there's no AJAX-y stuff going on, so your TCP sessions open and close pretty quickly. Maybe you don't care. Maybe VRRP is enough for you in that scenario, and that's fine. But maybe you've got a web service that's got sessions that stay open. Maybe you've got a web service that involves logins, and you have to be able to maintain sessions even if you're now directing to another host. So you might have to have some back-end synchronization as well. Those back-end synchronization mechanisms tend to be specific to the specific service. For example, our web servers use a very simple mechanism like this, and we have behind it a series of key store servers, Redis servers. I wasn't involved in their setup very much, so I can't speak to that very much. But the point is, the session information can get stored there, and therefore it doesn't matter which of the web servers you hit, you're going to still have your session. So we can go into some of those details if you have specific questions, but just understand that we're trying to be more generic here. The back-end synchronization is a little bit out of scope here, but if you do have a scenario in which you need to maintain your TCP sessions and you don't want to make the clients reconnect, well, then you need to synchronize them. And thus we come to conntrackd. Now, conntrackd is something that I didn't know about until just a few years ago. VRRP, I've done that forever, but conntrackd has been around forever. I just didn't know about it. It's essentially a daemon that can run on Linux that provides an easy way to synchronize TCP and UDP state tables between two Linux hosts. And since it is pretty commonly used with VRRP and more specifically with keepalived, it already has scripts to use to integrate with those notify master, notify backup, notify fault events in keepalived. And we'll talk about how that all integrates in just a minute. Let's see. So just so you can kind of get a sense, this is some of the details. Billy extracted this earlier about how the kernel actually keeps track of a number of events involved in both UDP and TCP life cycles. These go through several stages. One very interesting point, at least, oh, you can't even see it on the projector. There's a red colored number right here that represents the remaining time when it's in established state, which at least as of, was it kernel 4.17? I'm not sure exactly when this happened, but once a TCP socket gets established, once it's in the established state, it can stay there with no other traffic for about 5 days by default. But that can be tuned. I don't know if that's really important to you, but it's kind of interesting. Now, if it goes to another state, if it goes to fin wait or something like that, which occurs when one side sends a fin packet saying I'm ready to close the socket, then they each have their own timeouts. But when it's in the established state, it can last for quite a while. This is a piece of the kernel code. It defaults to 5 days. We kind of already talked about that. You can tweak it with this proxysnet, or it's also available through syscontrol. Just like most kernel tunings, you change it, and it's pretty straightforward. The basic concept with conntrackd, though, is that when you set it up, you set up essentially a peering mechanism, and each device sends all of its TCP and UDP state information to the other device. Now, there's a concept of an internal table and an external table. The internal table is essentially the stuff that the kernel is acting upon right now, whereas the external table is just what is being kept track of, but that's as far as it goes. You can actually set up conntrackd so that it pushes things into the remote device's internal table, but we've had problems with that, so we generally don't do that. Basically, when a new connection is established on one server, it's in that server's internal table, and then it gets synchronized to the peer server's external table. In the event of a failover, in the case of, for example, the notify master event with keepalived, it triggers that script, and one of the things that script does is copy all the contents of the external table into the internal table. And so if you have an established TCP session and you go walk up and pull the power out of this device that's the currently active one, then when the other device triggers, it copies its external table, including that particular session, into its internal table. The TCP session can continue without with a little bit of a brief delay during the failover. But in theory, other than that brief delay, you're fine. It's actually pretty slick. And again, this happens right around the same time that VRRP sends its gratuitous ARP replies. So the packets coming to the server get sent to the other server because of the different MAC address in the layer 2 domain, layer 2 header. It's really pretty straightforward. The conntrackd tool, command line tool, does give you mechanism to look at the internal and external tables as well. If you want to go look at the details. Yeah. A couple of caveats. There is a conntrackd command line tool that lets you look at those kind of things, and it's essentially an invocation of the same daemon that's already running, the same binary. That has to do with the synchronization of state tables between the two devices. But just to be confusing, there's also a conntrack command line tool, conntrack versus conntrackd. And the conntrack tool you can also use to examine and manipulate these state tables, but it doesn't actually have anything to do with the synchronization. So the two are similarly named, just pay attention to which one you're looking at. Also, one of the interesting caveats here is that if your IP table's rule set is set in such a way that it accepts by default, you can have problems. And let me paint a scenario here for you. Failover event occurs. There's a slight race condition between which when happens first, the IP failover and gratuitously ARP, and the committing of the external to internal tables. So if the IP failover has occurred and a packet comes in, but the external tables that includes the existing TCP session hasn't been committed yet, and you have an accept in your IP tables rule, then your kernel is going to say, I don't know anything about you, go away and send a fin packet, and your connection gets interrupted. And the same thing happens if you have a default reject, because a reject actually replies saying, is ICMP reject, I think? Anyway, the point is it responds, whereas a drop doesn't respond. And so if you set up your firewall rules in such a way that it drops by default unless it's coming, you manage to tweak it and change it a little bit so that when it's active, it doesn't drop it, obviously. But that way, if a packet happens to come in before the table is committed, that gets dropped as opposed to being rejected. And your TCP sessions can actually be maintained that way as opposed to being dropped. Does that make sense? I realize we're getting kind of in the weeds with some of the details here, but I'm really trying to keep this a fairly high level. We have found it useful in some cases to set up a health check in keepalived based upon the uptime of the server. It's a gross, dirty way to do it, but it works. The idea is that the synchronization is not ever complete, but for contract. So you want to make sure that you give it time to synchronize before this server that just came up says, okay, I'm healthy enough to take over. You give it some time to synchronize. Then 3 minutes is probably enough. It's not a particularly big deal. And it certainly is not a problem if you just restarted a service. Say you manually migrate the IP address away and you're restarting the web server or something. It's probably going to be synchronized. It's fine. It's not a problem. But if it just has been rebooted for a kernel update or something, it's a good idea to give it some time. And it's really just 30 seconds might be enough. Honestly, I chose 3 minutes and it worked, so I haven't tried anything else, frankly. We have also run into some instances where the number of connections that the kernel can track is exhausted. And this has been a problem mostly with older versions of Debian. More recent versions default to a much higher level, but again, just like some of the other things we talked about, the kernel level, like that timeout, you can tune those. It's not a particularly big deal. Just pay attention to it. Maybe set up a cron that checks it periodically, and if it starts to get full, send an email and automatically update it or something so that you don't have a problem. All of this whole process does help us with failovers that are as a result of hardware or software failures, but it also helps us do this, and that's updates. We need to update, and this enables it in many ways. We have found that automatic updates generally work. There are exceptions, but generally they work. And at least in our experience, if you decide, I can just handle this manually, you're probably lying to yourself. And it's a very comfortable lie, but sorry, you're going to get busy. It's not going to not happen. And we still do this sometimes. We say, oh yeah, when we the big major ones, we'll take care of those. And there'll be news about it. And I'm sure there's ones we've missed. So we're trying really hard, and it's a multiple year process to set up automated updates so that this doesn't happen. And having said that, that can be kind of nerve-wracking because your services are updating themselves and rebooting sometimes all on their own, and oftentimes you want to do it during the night when you're not there because that's low traffic times. Yeah, test it. It can work. Just test it out. So if there's a problem, you know. Automated updates. Most distributions provide a mechanism to do this. In particular, we use a lot of Debian and Red Hat Enterprise, and so we're familiar with the unattended upgrades tool in Debian and the yum-cron tool in Red Hat. You generally set those up, and it automatically, once you install them, it automatically sets up a local cron or something similar to just run it on a daily basis or on some other interval. And so it's really pretty straightforward. This does depend upon the software that needs upgrading being installed from your distribution's repository. So for example, if you go and grab, say a MySQL or MariaDB, I guess it is these days, from your distribution, it's probably going to be included in updates. If you go grab the tarball from Oracle for MySQL, well, I don't know. Do they provide repositories? Does Oracle?
They actually do provide repositories.
Oh, bad example then. Let's say that you compiled it yourself for some reason. You needed some feature that wasn't compiled in by default. I don't know. But the point is that if you do have something that's not managed by your repository, these tools won't update it. So that is a problem, and we're still working on that. The solutions to those kind of problems are really, frankly, going to be individual installation specific. So can't really address that. But yeah, so those kind of things happen. But generally, most of your libraries, most of your kernel, your kernel packages, those kind of things are going to be managed by your repository, and it's really pretty straightforward. Having said that, things can go wrong with automated updates as well. So here's a picture to paint for you. Let's say that you have a kernel update and you don't know it, but there's some fundamental incompatibility between that kernel update and the software and the particular hardware that it's running on. And so you have two servers, they're updating themselves every day, and life is good. And then one night you go home and you come back and both of them are down. What actually happened was they both grabbed the kernel update, they both rebooted, neither one of them came back. Setting aside for a moment the problem of having them both reboot at approximately the same time, this is a problem for other reasons too, because if it doesn't come back, well, then your service is down. And in theory, if they don't do one at a time, the other one could have stayed up. So we prefer a little bit more of a dependency structure between them. And we'll talk about how we set this up. But, and maybe you're smart enough to do them different days, but maybe those days were based on the day of the month, and this particular month they ended up on Saturday and Sunday, and you didn't see it until Monday. I mean, yeah, you can have better monitoring and stuff like that, but hopefully it's not necessary. So yeah, have fun with getting those servers back up in that scenario. So instead, we have chosen to do it a little bit differently. We generally set up a cron or other similar periodic run instance to update, but not to update itself, to update its partner. And so it can be as simple as install the update software like yum-cron or whatever, and but disable it from running locally by default. Set up an SSH key to the other server, and on Mondays and Wednesdays, server number 1 logs into server number 2 and tells it to update. On Tuesdays and Thursdays, number 2 logs into number 1 and tells it to update. And what this creates is essentially kind of a rudimentary health check. So if server number 1 goes down and doesn't come back, nothing's going to update server number 2 because number 1 is the one doing it, and it's down. So it provides a little bit of redundancy there. If you have a 3-node cluster that requires 2, like Redis, for example, you have to be a little bit more clever about it. You create things that go out and do a health check on the other 2 servers before updating yourself. And it's a little bit of a different approach, but it works pretty well. You confirm that the other 2 are healthy before you do it yourself, and then you end up with a 3-day cycle. Just as a general idea, you might want to choose to do these based on the days you're likely to be in the office, just so you know. Again, it depends on scale and a number of other things, individual company policies. Maybe that's not possible, but we've had a fair amount of good luck with this, actually. A couple of notes about yum-cron. If you do use yum-cron, be aware that I know of one particular Bugzilla report about it, and it's mostly about a reporting thing, and I know about it because I submitted the bug report. At least as of Red Hat 7, the code that they use to generate email notifications, because you can choose how you want to be notified with yum-cron. The email generation does not include the date and time in the body of the email, and it does not include a date header in the header of the email. And I'm not sure you're familiar with this. If an email arrives at your email client, at least with Thunderbird, which is what I choose to use most of the time, without a date header, then Thunderbird will assume that it'll apply the date and time that it first saw it. And so if you shut your machine down over the weekend or something, and there were updates that went on in the background over the weekend, you come back, as soon as your email client launches, it's going to look like, oh, this happened right now. Well, really, it happened 2 days ago, but you don't know exactly when it happened because there's no date header, no date or time information inside the body of the email. There is a patch associated with this Bugzilla report. It's really straightforward. It's 2 lines of Python. It's not a big deal. But it bugged me, so I submitted a bug report, and they've basically sat on it, done nothing for several months. So, and frankly, it might be already fixed in Fedora. I don't use Fedora particularly, so I don't know. We pay for Red Hat Enterprise, so I figured they would do it, and yeah. As I mentioned earlier, if you are using this update the other guy kind of approach that we talked about, you're going to want to make sure to do things like stop, disable, and mask yum-cron from running on its own. It's a system control service. Whatever your opinions of systemd, at least on Red Hat 7, that's the syntax to use. Yum-cron does not have the mechanism to decide when to reboot. The most common scenario in which you would need to reboot is when there's an updated kernel. So you may have to write out a simple wrapper script that basically runs yum-cron, then compares the current running kernel to the most recent installed kernel, and if they're different, then reboot, something like that. And then that's the script that the cron from the other server calls instead of calling yum-cron directly. But it's really pretty simple. It's a few lines of bash. It's not particularly difficult. With this is Debian. With unintended upgrades, they actually do have the automatic reboot when necessary. I guess Debian packages have a mechanism to flag that reboot is necessary in the metadata of the package. I didn't know this, but apparently they do. So I didn't really include any information about that here. But just be aware there's a couple of these files where you want to do things like this to tell it don't update on your own, so that you can disable the update itself, so you can then trigger it from the other server. And you get to choose in this other Debian file what repositories you want to pull packages from. So if you don't want just the updates, you can turn it off, and it works just fine. Any questions to this point? I feel like I've been talking a lot. OK, all right then. That's basically all I had. I can whiteboard some specifics of some of the scenarios that we've done this with. We can talk about specific scenarios you guys have, but yeah, that's really all I've got. So, anyone? Okay, well, hopefully it's been useful to you. If you guys have any questions that come up later, let me know. Oh, good.
One question I have on
conntrackd, and maybe it's just because my experience, most of our TCP sessions are very heavyweight. There's a lot of things. There's a lot of state involved with the
Sure.
TCP session, and so just switching over the TCP state at the OS level doesn't seem like it would be overly beneficial, except for just a handful of protocols.
Well, that's what he's talking about is a NAT server.
Well, yeah,
The actual server that you're connected to is behind.
yeah. So we did talk about a NAT server as an example, but you're right. If there's other things on top of the TCP layer, in terms of state information, maybe it's at the IP layer, maybe it's the application layer. Yeah, you've got to have a provision for synchronizing that. And that's really application specific. And I can't really answer that. I mean, we can talk about if it's a common one. We might be aware of how to do it, but I'm not entirely certain. Yeah.
So the scenario I was thinking of is if you have a client connecting to a web server,
Mhm.
the actual server goes down in the middle of responding to that request. So you have a TCP session that never closes, essentially. It's going to time out, I'm guessing.
Yeah, I'm going to guess that would be interesting. Theoretically, your client should have a mechanism to reconnect. TCP
Right.
does have those things built into it, and even the application layer can handle it too. If the actual TCP session, like in the middle of a transfer or something, are you talking about a scenario in which the web server is managed this way, or some kind of a proxy or NAT server is in between them is being run this way, or both?
Well, I'm thinking if you have like a load balanced web server, and the actual server that's responding
Dies.
gets the essentially gets the power yanked. In the
I
middle
am
of
not.
a response.
Well, it would definitely time out at some point, and presumably your client would reconnect.
I
Or
was just trying to think worst case scenario.
yeah, that is a pretty bad one. I'm not really sure. Billy, have you did more with the web servers than I did. Do you know?
So the most we did on our side, I don't think it actually answers your scenario of what you described, but we set up VRRP for the floating IP between the two. And our concern was actually sessions. We wanted to keep the sessions the same. If they switched to one or the other, we don't want to keep sessions locally on our web server. So we broke that out to these key value stores that were behind it. I'd imagine if it's handled locally.
You have redundancy set up in the value.
Yeah, so that's per session. So I'd imagine that if you're trying to handle long downloads, then that somehow has to get broken out from the actual web server in a way so that's it's redundant.
Hopefully your web server supports resuming
Right.
downloads.
And my suspicion is that what would happen is, say you were loading a large web page, and then a failover event occurred. Then it's possible that specific page load would fault, and the person sitting in front of the browser say, "That's weird." Reload. I would hope that would be enough, but I'm not 100% certain. And frankly, for something like web that is well understood in other contexts, this whole approach may not be the best one. There are probably solutions that are specific to that kind of a platform that involving reverse proxying that make more sense for some of these kind of scenarios. I'm not entirely certain that this would be your best choice there, but yeah. The real applicability here is to be able to maintain IP and TCP and UDP synchronization between the servers. If that's not enough, if there's some back-end synchronization needs to happen, great. If there's some other state information, or if it's absolutely critical that a particular TCP session never get interrupted, you've got a much bigger challenge ahead of you than this can solve. This is tough.
I think part of it is in the name of it. It's because the VRRP is virtual
Router redundancy protocol.
Yeah, router.
I think it was originally designed for IP addresses that float between
You
routers.
have a NAT, you're acting as a router,
Right.
and it's the routing that.
It's essentially the most convenient IP failover mechanism that we're aware of. But there might be better ones.
Redundancy for, well, at least with conntrackd, what you're doing only really, I guess if you don't use conntrackd and you're just using
VRRP.
then I guess it wouldn't really matter. But conntrackd it seems like its benefit is when you are acting as a router.
Yeah.
Yeah.
It's not for services themselves, it's not gonna help their.
Yeah, that's certainly been where we've applied it the most. We did it in the NAS servers. It's not fully done yet. It had some problems, but I'm actually going to fight some other fires and get back to it. Working on a setup that uses essentially two of those active-passive pairs on the same hardware to do fabric switching between IP over Ethernet and IP over OmniPath. If you're familiar with OmniPath, it's similar to InfiniBand, but Intel decided to buy it and make it different. I'm going to stop there before I get somebody in trouble.
I can mention something also with VRRP. Something that's been nice is when you have one floating IP, you're accessing only one server at a time, right? So you're wasting one
Right.
server. So we'll set up, and you can set up multiple floating IPs and they're weighted so that you can weight one towards one server and one towards the other server, but everything's else. So that in a healthy state, these two servers each have their own floating IP, but if either fails, a floating IP will float, one or the other.
Right. For example, our web servers are run this way, and there are two of them, and there literally are two floating IP addresses, and either one could be on either of the two underlying servers. But normally they're split, one here and one here. And so if one of these web servers were to die, the other one can take over and run both IP addresses, but when it comes back, then it floats back over there again. I don't think we're using. Are we using conntrackd on the web servers? We're not, are we?
No reason.
Yeah.
It doesn't help anything.
Right. So yeah, that is a common approach. And then what you do, you've got two IP addresses. You just put them both in. You just have two different DNSA records, and the client decides which of the two IP addresses it's going to point to, and it doesn't really matter which one they choose at that point. And again, the backend synchronization of web sessions, and you're good. So there are lots of things you can do. Whether or not it's the best choice, it depends on the scenario. As one of my undergrad professors, who's now retired, used to say, the answer is it depends. It depends. So, yeah. Anything else? All right, well, hopefully it's been beneficial to you.
Thanks a lot.